there are some elemental gases that you need to know about. There are some elemental gases you need to know about. All the noble gases are always gases. They're called gases, right? Okay. Hydrogen, nitrogen, oxygen, fluorine, and chlorine. Hydrogen, nitrogen, oxygen, fluorine, and chlorine. When hydrogen, nitrogen, oxygen, fluorine, and chlorine exist alone, they're not ionic, they're just elements. They are always diatomic gases. If they're just existing alone, they're always diatomic gases. So those you just kind of have to memorize, I guess, but you can also remember where they are on the periodic table. That might help you because this is kind of an L right here. They're all grouped together, nitrogen, oxygen, fluorine, and chlorine. All you got to do is remember hydrogen over here, right? And really, it could fit right there too, so you could make a T right there, I suppose, all right? They're always diatomic gases. So if you have those in a formula, they're gases, right? All right. You were asking more questions, Marissa? Were you asking? All right. Now, in an aqueous environment. Now, an aqueous environment means there's water around, right? Then you're going to know whether you have what the physical state is. You use the solubility rules. Okay. And we've been practicing with those for over a week now. Okay? So you just look at the compound and see if they're going to be aqueous or not. All right? Now there are other compounds that are aqueous besides these, but we haven't dealt with those, so I would have to give that to you for you to know. All right? Okay. Okay. All right. Todd. No, I'm Tater. She's Todd. Go ahead. Yeah, she's Taylor. I'm Tater. She's Todd. What? You know what they used to call my children when they were little? They used to call them tater tots. Okay. Go ahead, Tot. That's right. It's her 15 minutes of fame. Go ahead.
It says, what's the sum of the oxidation numbers in a neutral compound? And typically says, what's the sum of the oxidation numbers in a positive charge of the ion?
0 and the charge on the ion.
Huh?
The first question you asked, the answer is 0. Remember, anytime we put together a compound, we had to get a 0 charge overall? That's why.
What about in polyatomic ion?
It equals the charge on the ion.
I want to do that. You asked me the question. I know it was like that on my sheet. Now what's that?
All right. Yeah.
Okay. You know how you said that some of the little subscript numbers don't get moved around? What's the rule for that?
Okay. When you're predicting the products of a reaction, subscripts do not travel unless they're part of a polyatomic ion. CuCl2. Is there a polyatomic ion in the formula? Then that subscript won't travel. Yes, PO4. Well, I assume you mean PO4 with a 3 negative charge, the phosphate ion.
Well, really, I'm asking about 112.
Huh?
I'm asking about 112 question.
Well, what's it bonded to? What is the formula that contains the PO4?
Na3PO4.
Okay, Na3PO4.
Was the 3 travel?
The 3 does not travel, but the 4 does. The 4 is part of this polyatomic ion.
So it only travels if it's on a polyatomic.
It only travels if it's part of a polyatomic ion. Yes.
The only time.
Huh? The only time.
What does that part mean about taking place in water? Not really stupid.
So it's
Any compound that's...
this is solubility rule.
Yeah.
Okay, that makes sense.
Right.
My turn.
Sure.
Number 66, when sulfur and chlorine combine, what holds the
Okay, I think we're going to have to pause a minute. I'm sorry. I apologize to you. On behalf of the people that...
On behalf of me, I'm sorry.
All right. There you go. Go ahead.
Alright, number 66, it says, when sulfur and chlorine combine, what holds the compound together?
That was the question that was asked earlier.
That's what I was trying to keep up with, I couldn't figure out what number it was.
Well, that was the one about when you share they share electrons to get a full valence level, and the full valence level makes them more stable.
Okay. Wait, just one sentence real quick. So the full valence level.
So Amber, will you yield the floor to Todd?
No, it's just a yes or no question. It's not.
Yes. Well, Amber's hand went up first. Go ahead.
Oh, like, when you say what's the shape of a PO, you want us to draw it?
Sure. Well, or tell me. You can describe it verbally.
I mean, I know it is, I just want to know if you want to draw it.
No, a p orbital isn't spherical. S orbitals are spherical. P orbitals are,
Two balloon shapes.
well, yeah. And actually, it's the top half of the both balloons, not really the whole balloon.
Oh, 78.
Yeah. All right.
So the p orbital shape.
We did p orbitals like this. Okay? That's the way we made them when we made balloon models. However, I also told you in Unit 2 that the actual orbital is only the top half of both these balloons. Okay?
And the S shape spherical, and the S orbital spherical.
S orbitals are spherical. All right.
Wait, what did you say? That's where the half part, the orbital, is only the top parts of the circle.
Are you waiting for?
I am.
Man, Tom, be quiet.
This is the shape of a p orbital.
And the orbital is only really the top part of it. Or the
Yeah, the p orbital is made of both this and this together.